Hi, professors. We are Team BodyMetrics. Our project focuses on developing a virtual reality therapy for the relief of neuropathic pain. This pain is characterized by a shocking, burning, or freezing sensation and occurs as a result of damaged neurons sending pain messages to the affected parts of the body. Our VR therapy seeks to alleviate the pain felt by patients by immersing them in 3D environments to distract them from their pain. Dr. Petrino's current pilot study involves the use of a Samsung VR headset to immerse patients in a VR environment of a previously recorded video in which outstretched arms perform ordinary daily tasks, such as typing on a computer or playing cards. The pilot yielded positive feedback from patients in relieving or distracting them from their pain, but their main complaint was that there was a mismatch of body features between the person in the video, which was Dr. Petrino, and the viewer, specifically in their skin color and amount of hair on the arms. This brings us to our needs statement. We are aiming to develop a method for improving rehabilitative therapy for patients with neuropathic pain, using a customized virtual reality environment to enhance user engagement and satisfaction. So to do this, we had to set a timeline for the semester. So far, we have successfully completed 2 independent environments on Blender, as well as avatar arm rigging. Over the past week, we have been working on integration of these 2 elements in Unity, which is our VR game engine. We are currently attempting to view the environments on the Samsung Gear VR. After figuring out how to transfer the completely rigged arms into Unity, our next step is to animate the avatar limbs in the actual environments. Mid-April, we will render and view the final product on our VR headset. To ensure that our environments and avatars are realistic enough to enable immersion, we will have our classmates and friends try it out and take surveys about their experience. Lastly, we will make any necessary changes before BME Day.
As a reminder, last week we presented 2 independent dynamic environments in Unity, which you can see in the 2 top screenshots, as well as a pair of rigged arms in Unity on the bottom left, and a scalable set of features including muscle tone and gender on the bottom right, which were all presented and created on separate files. We also had a pair of arms from our target point of view in Unity prepared by one of our team members in an attempt to prepare for animation once the components showed previously were integrated. Our next steps, as we mentioned last week, and as Denise discussed on our timeline, is to have these environments integrated. And to do so, we spent the last week working on the Unity Cloud, where we can turn on the collaboration feature to share and combine one another's progress. As you can see in this screenshot of my cloud account, I have access to all of my team members' files and can download, manipulate, combine, and then re-upload to the cloud for the rest of the team to access, so that we're always updated on one another's work. This is how we achieve the progress that we're going to show next in our screenshots and in the demonstrations later on.
So the progress that we've achieved so far goes to the arms rigging in Blender and transferring them to Unity. Here we see some rigged arms in Blender, and you can see here on the bottom left how every finger element has been rigged with the skeleton so that they can move appropriately and perform actions like picking up snowballs or warming their hands by the fire, and create an immersive environment where the patient is able to have a therapeutic experience. Here we have an integration like we were talking about, where the arms are able to be put into the environment that was created. And this is in the Unity software. And you can see the fireplace on the left of those arms there, and a couch and a living room environment. And that camera icon that you see will be focused in on that living room environment and from the point of perspective of the arms, like you saw in that pink arm slide, but this time with probably configured arms that were made in Blender using a 3D modeling component. Next slide. So here we have another avatar, but this time it's a full avatar, and it's a controllable avatar in that same living room environment. And as you can see the scene setting in the center which shows you the living room environment in context with the rest of the scene and the avatar. And what you'll actually see in the game is the camera view. So I showed you that camera icon in the slide previous, and here you can see what the user is actually seeing. It's basically that camera view can be manipulated to show you whichever part of the living room that the developer wants you to see. So for sponsor updates, we emailed a sponsor regarding the level of control that they'd like to have and the level of texture that we've created in our environments. Since the second slide showed you that they were immersed in actual 360 video degree environments, we wanted to make sure that the environments that we created in the VR environment was satisfactory. And we got a reply back that they were looking great and that we were ready to go ahead with the environments that we created. Secondly, he mentioned that there was supposed to be physician control on a separate device and hands-free on the Android. So for neuropathic pain patients who might be paralyzed from the neck down, they won't be able to do anything with their limbs, and therefore it's clearly just an immersive environment for them to experience. Therefore, without having any control, the physician would like to have that control transferred to a separate device where he'll be able to manipulate the avatar or the environment appropriately according to the patient's needs and provide a therapeutic experience. Our next steps, therefore, are to get that rigging from Blender that we showed you in that slide with the arms into that Unity and be able to control the arms just as we were able to control the avatar. We also want to view the integrated environments on an Android device. We've already been able to view environments and avatars on an Android device, and now we want to transfer the environments that we created with the arms that we created and rigged into an Android device. And last but not least, referring to the email that we got from our sponsor, we want to consult on HTML compilation, which might be the only way for us to have control on one device while simultaneously broadcasting on a separate Android device. So now we're going to go on to our demo, where Wilson and Andrew are going to show how they rig their arms, what scalability they have, and how we're going to transfer those from Blender into Unity.
So this is the environment that Denise made the fireplace in the living room, which I believe everyone has seen before. However, what's new is that we put my arms in here. So these arms were made in Blender, and now I can fully control the muscle tone, how much fat it's going to have, and male to female transition. So later on we're going to put a slide bar in for a minimal functional product. It's still easily controllable just from using the menu, but we're going to put a slide bar independent that has all these properties that they can slide from 0 to 100, and they can control in the future. So this is a quick demonstration. So the first thing I'm highlighting here is the female transition slide. So it goes from 0 to 100. So I click 100.
What? Yeah.
Becomes female arms. It's a bit hard to see, so I'll just increase. So it's a bit hard to see because the arms are a bit small, and I can't increase the slide. I can't increase the size of my screen. So I move into muscle tone, which is a lot easier to see. But as you can see, they're visibly more muscular. And if I also increase the fat as well. Yeah, and also all these parameters overlap with each other, so I can also increase the amount of. It also makes it and having the fat arms as well. So this is fully done. The meshes are fully set up. We just need to finish rigging these arms, which will be done within the next week. It's just that Wilson went ahead and finished his rigging on his arms, so he can get a better idea how to rig these arms, and then he can go back and quickly rig these arms. However, just for this midterm presentation, we decided to show Wilson's arms fully rigged in an environment, just to demonstrate that we can have fully rigged arms. And yeah, so I'm going to give it over to Wilson now.
All right, so now I'll be discussing the kind of animation that I have made on Blender, which I will transfer to Unity. But the first thing was for me to create these animations and manipulate them however I want to make sure that when I do the transfer from Blender to Unity, we still get that same flow to avoid any interruption. So I created a frame shots from 1 to about 84. So I will show you how they play out and the kind of movement that the avatar will make, or the avatars that we create will make in the Unity environment if we were to transfer them. So as you can see, it goes from 1 to about 90. And you can see the kind of movement that is made, like grabbing something, trying to interact with the environment in some manner. There will be other frame shots that will be made of this with different postures, just to reflect the multiple interactions that we will want this avatar to make with the environment. But this is just the first one. And the next step from here is to transfer this animation into Unity, and finally into one of the environments that was created, and see how that goes. It's not easy, so I'm trying to really make some tweaks about it to make sure that the camera comes around to the perspective of the avatar, and so that by the time we transfer this, you really get a very virtual reality feel between the avatar and the environment completely immersed together. So that's the first thing I'm doing. Yeah, this is a demonstration, and we'll take it from here, and that's where my project stops for now until maybe next week. I'll give you something else. And now it's actually in an infinite loop. So I allowed it to go on for a while, but after the animation, it will stretch out for a certain amount of time, say about 20, 30 minutes, or depending on how long we'll decide to make this. And after that, the avatar will stop moving. But it will combine a variety of movements, combinations of movements and interactions, depending on the environment and depending on the patient. Yes.
So that was the presentation and our update from last week. Thank you and goodbye.